Hey, what's up, guys on YouTube? What's up, Zai myself? We're gonna be doing an exciting run today. Let's get started here on Instagram and TikTok. We got some excitement. Some excitement. So I tell you right now, it's about to go down. Alright. Should be good in a second. Right, Facebook, cool. Alright, we're good, we're good. You said, do I build it myself? Yeah, everything that you see, I have built by hand, myself. That's how we rock. That's how we rock around here. All right, Instagram, and we good. All right. So, today, we're really going to be focusing on that natural gas product. Okay? We're going to be loading in plastic while the machine is running. Okay? And, most importantly, we're going to stay safe while doing it. What else? Oh, TikTok is still loading up. What else? Well, we're going to make a lot of natural gas, okay? We probably are not going to make liquids. So let's get the expectations right from the start here. Okay, because we're probably not going to make liquids because I still need to add probably 1 or 2 more magnetrons before we get liquids. Okay? And that's just the truth. Okay? But I'm going to be adding those 2 magnetrons very soon. Tomorrow and potentially, what is it? Saturday? Tomorrow and Saturday. So, today we're making natural gas. That's the focus. I don't know why TikTok isn't loading. But if it doesn't load soon, we're just going to go anyway without it. Hey, much love to Pakistan. What's up, guys, on Instagram? What's up, guys, on Instagram? And I'm glad you guys are here showing some love. We're about to do a continuous run of this machine, meaning we're loading in plastics while it's running. Okay? Yeah, alright. TikTok still isn't working. Maybe it'll load in time. So, let's go ahead and get started. I got a lot of plastic. So we're going to put a lot of plastic in to start. Okay? And then we're going to load in plastic while it's running. Thank you for the badge, Punk Ozzy. I appreciate you. Thank you for the $5 on Cash App, David. I appreciate you guys. Thank you very much for the early stream love. Let's go ahead and load these plastics in. Okay, so we loaded in about half of all the plastics we want. Unfortunately, I got unlucky. Sometimes a draft came through and blew some. I hate that. So I'm clearly going to have to make this hopper even bigger so we don't have any type of plastics leaking in the future when I do that. But we loaded in about half, and we're going to be putting in the other half while the machine is running. Once it gets nice and hot. One second, I was just trying to see if I could figure out why TikTok isn't working for me at all today. But nonetheless, plastic is in. Now we got to pull a vacuum on this on the machine. Why do we have to pull a vacuum? We have to suck out all of the air so we have no oxygen in there. Because if we have oxygen, then what's going to happen is the oxygen is going to react with the plastic when it heats up. It's going to form oxides. And then instead of the plastic turning into fuel, it's just going to catch on fire and burn. Okay, so unfortunately, I don't know what's going on with this TikTok, but we are not able to get this started no matter what I do. That sucks. Okay, so that's pretty much what we're going to do. So we're going to go ahead and pull this vacuum. And then, so I'm going to actually show you guys. You'll be able to visually see me pull this vacuum, okay? You're going to visually see it happen, and I'm show you how. Okay? All right, so what you guys see here is a yoga ball. Hey, Zai myself, can you keep the Cash App pinned in the YouTube if they'll let you? I appreciate you, man. So, this is a yoga ball. Now, this yoga ball is actually full of natural gas made from plastic. Well, it's not full, but it has some in there. What we're going to do is we're going to pull a vacuum on this thing. Then we're going to hook up this yoga ball. Well, actually, we can hook it up now. We're going to open this valve, and what's going to happen is, well, this yoga ball is going to get sucked dry because all of the natural gas in here is going to get sucked into the chamber because it's going to be negative pressure, and this will get completely dried out. And then when we see this yoga ball start to fill up again, when we turn the machine on, that lets us know that we're starting to actually create fuels. And so it's a good visual confirmation. I have a pressure gauge as well. But so let's go ahead and suck all the air out of this machine. You're not going to see anything until after I open up this valve. So let's go ahead and do it. I got my wireless system, my keyless whip system to go ahead and turn on this vacuum pump. So right now I'm sucking out all the air. This is my my gauge. This is a pressure and vacuum gauge. It's used for the automotive, but it works for me. The thing about this gauge is it moves so little for something this big of a volume that you can barely tell. But you can see, if you look at it, you see the zero. It's below zero, so that means the vacuum is being pulled. The needle is below zero, so we are already starting to pull a vacuum. Okay? And we're just looking, we're looking to just get all the air out. We're not looking for the perfect vacuum. Wilton Lee, thank you for the $8 donation on the Cash App. He said, keep up the amazing work, bro. Hey, always will. I appreciate you, Wilton Lee. All right, look, so now we're almost at 5. You see? This is negative, okay? So we're at 0. We're almost at -5. We're pulling it back in. We're sucking things dry, all right? Pause. All the way Diddy on that one, all right? So, like I say, we're not looking to get a perfect vacuum. We're just trying to get most of the oxygen out, okay? It doesn't have to be 100%. It doesn't have to be perfect. But this is about good enough for what I'm doing, okay? This is all we need. All right? So watch what's going to happen now. Turn my vacuum pump off. Close my valve. And I'm going to open this valve, and you're going to see this yoga ball is going to get sucked. Sucked dry quickly. Maybe not that quickly, but watch. It's starting to deflate pretty rapidly. Okay? And once again, this deflating lets us know this is indeed under vacuum, so we don't have vacuum leaks for 1, okay? Because it'll be sucking in air. And for 2, this will let us know when we start to make vapors this thing will start filling up. So now you see it's dry. My ball just got sucked to dry. All right, I just sucked my balls dry. So now we turn the machine on, okay? We got no oxygen. Now this entire atmosphere is filled with natural gas, but there's no oxygen. So it can't explode or catch on fire because there's no oxygen, okay? So now we turn it on, and I'm actually gonna turn the blades on too. We're gonna have the blades spinning the whole time, okay? So I put on all my safety stuff when I do this because we don't know what's gonna happen, okay? And we do a small prayer too. We always do a prayer before we turn this on because you never know what's gonna happen. Well, all right, we got all of them on. We got all 5 magnet farms on right now, guys. So this thing is going to be getting hot quick. Now, I'm going to back all you up because I personally, when I first turn this thing on, I don't like to be super close to it. That's just a personal thing, okay? I'm just saying personally. For safety, I don't like to be super close when I turn it on for the first good few minutes, because if it's going to explode, let me not be nearby. But pay attention to the yoga ball, okay? Because as this thing is going to start making natural gas and plastic is going to be turning into fuel, this yoga ball is going to start filling up. Okay? It's a good visual. It's a visual thing. Now it's gonna be slow and it's gonna take some time. But so long everything is good, which it appears to be, then it will be fine. Oh great, Facebook went out. Let me get Facebook plugged back up. So I'm looking at it, and it looks like the yoga ball is already filling up. Hey, thank you for the $10, Felicia. Felicia Portugal on the Cash App, I appreciate you. You look at this, guys. Yoga ball's already getting filled up. My balls are already getting filled up. All right, I'm not sure what's going on this phone. It is not accepting the Ethernet. Facebook is going out. By the way, guys, on TikTok and on Instagram, you want the best quality live stream, head over to the YouTube live. I'm live on YouTube too. Okay? Thank you for the super chat on YouTube. Let me see who sent the super chat. Oh, it's windy out here today. It's Bun. It's Bun J. Thank you for the super chat on the YouTube. I appreciate you. It's really windy. I'm sorry, guys, if the mic is bad. It's really windy out here. So far, everything looks good. We're not having any issues, no explosions. Everything's running. Temperature on the machine is rising. Yoga ball is slowly being filled up. It's going to start to become exponential, all right? The blades are on, by the way. So, we're actually going to want to start loading in plastic pretty soon. Because we want to keep the ball rolling, okay? But it takes time for these temperatures to get where we want them. You know, it takes a little bit of time. The microwaves work very quickly compared to regular heat, but it still takes time to heat up, you know, metal, no matter how you put it. Yup, the yoga ball's filling up. Take a look at the sight glass. Sight glass is becoming foggy. That means we're cooking, guys. We are cooking. Can YouTube see the sight glass? You guys on YouTube. If you look at the sight glass right here, the sight glass is becoming foggy. That means that plastic is being turned into crude oil vapors. The crude oil vapors are making it up through the pipes, going through the condensing system, and thus filling up the yoga ball. Yoga ball is actually filling up pretty quick now. Okay? I can literally see it growing. Thank you for the $10 and hell on the Cash App. I appreciate you so much. Oh, great. I think that's a leak. Yup, that's a leak. That was a gasket right there. We just had a gasket blow on us. Unfortunately, gotta shut it down. Great. Yep, we had the fifth magnetron just blew its gasket. Now it was not any type of explosion, fortunately, but unfortunately, I can't run the machine with a gasket that's been blown, because when the gasket is blown, that means that these vapors that we want to collect are now escaping into the atmosphere, right? So the machine is no longer operating under the pressure we want. Now, it's not a bad leak. That's why you can't see it, but I heard it and I saw it. It's this one right here. I'm going to show you. This one right here, the gasket between the microwaves and the chamber, which is like sandwiched in between, it just blew. Unfortunately. Thing is, I'm still researching. I'm still in the research and development phase for the best and most consistent gasket material. Because I have gaskets, for example, this gasket here that just blew right now, it's been working fine this whole time. We ran this machine probably 6 hours yesterday. It ran fine. But why did it blow today? Right? I'm still trying to figure out the most consistent materials to use, because you can't just use you can't use anything, because you have to use a material that's resistant to microwaves too. So, you know, we're still in the R&D phase. We did get some natural gas, but unfortunately, there's just no way that this thing got hot enough in that small amount of time for us to get any real result. I mean, it's the body is definitely heated up for sure. Yeah, the body is warm, so it was starting to get there. That's why we got natural gas too. But what? That was like 15 minutes, and it sucks because these gaskets, I mean, to be honest with you, they take some time to replace. Hey, but you know what? I'm gonna try something. I've never done before. We're gonna replace the gasket right now, live. I've never done this on live stream, okay? This is a type of behind the scenes thing nobody sees, but this is what I have to deal with every day. We're gonna replace it live, and if we can get it to work, then we might be able to run this machine, start it back up, live, okay? So let's do it, let's see. Let's see if we can get this done, okay? And if we can, then we can just get the machine started up again right now. I never do maintenance live, or I never even show maintenance on videos either, because it's, you know, dangerous thing here. So, by the way, guys, I make sure all my stuff is unplugged before I touch any of this, okay? You got me messed up thinking I'm going to touch anything with these high voltages being plugged in. So yeah, I mean, we'll see. I've never replaced it live. I always, usually when the gaskets go out, that's the end of the live stream. 9 out of 10 times, but you know, maybe it'll be different today. We'll see. But the first step is we got to take off the magnetron and the fan. That's what you see on here right now, okay? It's pretty simple. It's just a whole bunch of screws. Okay? So take off the fan once again, unplug everything, and all these things have capacitors, meaning even when it's unplugged, you'll still get shocked if you touch the wrong spot. So take the fan off, boom, just like that. Unplug the magnetron, because we got to take it off next. All right, then take off the magnetron. Try not to get these bolts and screws everywhere while I do it. All right, magnetron off. So you see, this is what creates the microwaves, right? And you see it's mounted to the waveguide, which is mounted to the body of the machine. The gasket we have is in between these two sections. But it's not a traditional gasket. You probably are thinking like an O-ring or something. You're going to see how this differs from a regular gasket in a second. Actually, it might take longer than a second because there's so many damn bolts on this thing. And it takes a second to get them on. It takes way longer to get them all on than it does to get them off. Because I can get them off. You know, with I can get them off, you know, without a wrench. Some of them. Most of them. Some of them still need a wrench, though, to get off. Yeah, like this one. Where's my wrench? So, you know, we'll see. It's kind of hit or miss, because here's the thing about these gaskets, right? When they blow, we put down RTV silicone, right? We're using the gaskets to help fill in the imperfections. But that RTV silicone takes time to set, like at least 24 hours. But here's the thing, a little cheat. Microwaves actually cure it very quickly. But the issue becomes, if it's under too much pressure before the microwaves cure it, it's going to bust open, and you know, you might end up wasting your time if you don't let it set. But I've actually had success with just turning it on right after I put the RTV on, right? Without even letting the RTV set. So there's always a chance. There's always a chance that you know, you're not gonna have an issue. We're gonna see today. Just for the sake of trying, I was really looking forward to running this, so I really don't want to not run it just because it wanted to blow a gasket 15 minutes in. That was a little bit too early. Like maybe if it blew the gasket an hour or two in, you know, after we got some natural gas, it would have been different. But 20 minutes? Come on, that's a little bit too early for me. All right, final one. There's so many bolts. This thing takes so long to get on here, I'm telling you. So I'm like, I don't do this maintenance live or even on video because it's just tedious. But this is really the only point of failure on this whole machine. Everything else is solid. But these gaskets are the weakest link because they have to fulfill so many material properties. So many. It's so much more than just a gasket. It has to, you know, like I say, be temperature resistant, chemical resistant, microwave resistant. So now look, there's the actual gasket. And like I said, it's different than what you think. You probably think, oh, it's just around this. No, the gasket actually has to be completely cover the whole thing because gases cannot just come right through this. This is hollow. The microwaves have to go through. So it's a different type of gasket. And if we actually take a look at this, the gasket itself is completely fine. It's not broken or destroyed. It's just the seal around the edges that had come off. Okay? That's all that happened. That's why I say we use that RTV around the edges, but I'm going to replace the whole thing with a new sheet just for the sake of, you know, wanting to keep it consistent. Oh, you guys on TikTok can't even see. Let me move this over. So you guys on TikTok can see everything I'm showing everybody else. Boom. So now this is the wave guide right here. This is the wave guide without the thing, and you see there's some vapors escaping. Those are the vapors of the chamber. Normally I'd vacuum out the chamber before I do this so we don't have this issue, but since I'm wanting to restart the run, right, I'm not gonna vacuum out the chamber because it's just not. So here's the thing. You really actually don't have to remove all this existing RTV. In fact, it's very difficult too. And sometimes it's not even worth the time. Right? I'll try to, but if it's gonna be extra, you know, you don't have to remove 100% of it because it does not. Silicone sticks so well to itself. I've noticed because I've been doing this for years that it doesn't really make a difference with your new silicone setting on top of it if you just leave it on there. So I'm just doing it now for the sake of it, but I really don't even bother. You know, taking off all this silicone. Oh, great. Instagram had gone out. All right, we should be back online now. My bad for the bad connection there. All right, so yeah, as I was saying, yeah, you just take some of it off, whatever. I get a little paper towel, we'll get the oils off. So clearly, the way how this gasket failed was not like the gasket was destroyed, which is a good sign, because that means that it did its job. It did not degrade under microwaves, nor heat, nor chemicals. So I'm still experimenting with different gasket materials, so that's good to me that it actually just popped off. It actually looked like we pulled too strong of a vacuum for it. So the vacuum we pulled probably exceeded the capabilities. Okay, so now I need to get my new gasket. I'm gonna go get my new gasket, and then we cut it out. You know what? Every day is a learning experience, and we could potentially find the next best thing. So I was going to use the same material for a second time, but I'm actually going to use a different material. This is a potential material as well that could work very well for gaskets. I know it looks very flimsy, but it actually is it's pretty much a super material. It has very good properties in every way. Now the wind is not helping. So what we got to do now is we got to RTV silicone around this thing, right? Actually, I like to cut out the shape of this first. But it's just so windy. It's so windy that it's not really making this easy for me. Now I've actually used this material before, a few times before, and it's worked. So I know it works, but this is a little bit different than what I've used before, just because of the thickness of it. So we're gonna see. I mean, this is gonna be the time to see if this works or not, right? We'll know very quickly. So you know, here's the thing, right? It doesn't have to be perfect at all when you're cutting this. You want it to have as much surface area contact as possible. So in a way, with it being less perfect, you might have more surface area contact. You see, got the full surface area contact. That's what you want. And it's coming a little bit over, so you just trim it a little bit. Trim it a little bit at the bottom. Boom. Okay, and now I'm gonna go get my RTV, and it'll just stick right on there. But it's so windy out here that if I don't get my RTV, it's gonna blow away. We don't want that to happen. So let me get my RTV right here. Okay, take the RTV. In fact, I'm actually running low. I'm running low on RTV as a matter of fact. So I hope we don't run out completely here, because this is a mandatory. This is mandatory, because there's no way that I, as a human, am gonna cut my metal so perfectly and so flush that it's gonna have a perfect metal to metal kiss. You gotta have the RTV to fill in your imperfections. And we compress this thing so much, you could put a very thin bead of RTV. I mean, you saw how many bolts I had on this dang thing, right? But you want it, you know, to encompass the whole thing. Now, as I was saying to you guys before, the RTV, oh, there's a little loose spot. I'll take that off. The RTV, right? What was I saying about it? Forgot what I was saying about it. Is it raining? Is it really raining? Come on now. Oh, the RTV, it sets under microwaves pretty well, actually. So there's a gamble. You have a little gamble when you do this, what I'm about to do right now, which is get this gasket on and actually start the machine as soon as we get it bolted down, everything back on, right? It's a gamble because it could actually be fine, but it could also succumb to the heat and not being properly set. This is very high temperature RTV, oil resistant. You know, this is heavy duty stuff, right? So all it really needs to do is set, and it's fine. But if you don't let it set, you can't blame it if it doesn't work, because that's your fault, right? So it's my fault if this fails. But like I said, I've done this a few times before, and it hasn't failed. So I got some overlap on my holes. See if I could trim that, because that will be a pain to deal with. Just a little bit of overlap. Hey, more overlap is always better than too little, because if you have too little, it's pretty much guaranteed to come off under any type of pressure. right? So want some overlap for sure, and boom. And I just like to do this to make sure that before I start to bolt everything down, that we do indeed have RTV completely encompassing the whole thing. You see that? It's completely encompassing it. So now when I take this faceplate, put it on, bolt it down under super high torque, it's going to compress it even more. So you can actually see the gases are already being stopped. So, this machine, pyrolysis, operates under almost no pressure. So it's not the pressure, it's not when we have this on where this usually fails, unless it's from heat. But this is a very high temperature resistant material. Unless the silicone fails, right? It's actually when we pull the vacuum, okay, or do pressure tests. That's when these fail. Or if there's a spike in pressure. But here's the thing though, even though pyrolysis operates under almost no pressure, I am going to optimize and tune my machines to where even though they're never going to operate under like 10 psi, that they can survive 10 psi, right? Because that's some nonsense if they can't. Nothing I'm going to create is going to be a little wuss, not be able to survive 10 psi, right? My piss comes out at 10 psi. So the least this big machine can do is survive that much too. So now you see I just put all these bolts on. This is the most tedious part. You got to put every single one on. You got to torque every single one down. Right? And this is why I say I don't show this stuff usually, because it's like in my mind I'm like, who wants to see this? This tedious nonsense. When a gasket blows in 1 second, I gotta spend 20 minutes diddling around with it, right? But it's a part of the science, because like I said, I'm still to this day experimenting on the perfect material, the perfect combination of things that I can do at home, okay? Because there's other materials like sapphire glass that costs $1,000 a piece. And I got 10 magnetrons. You do the math. That's not going to work at home. So, it has to be cost effective, has to be realistic for me to be able to acquire. And then it has to work. It has to be put to the true stress test and bear the test of time, Hey, what's up, Positive Being? I appreciate you as always, man. Much love to you. So I get all these nuts on, and then we go ahead and torque it down. And here's the thing, right? The RTV is really there just to fill in the gaps. The RTV is gonna be torqued down so much that, in theory, shouldn't pop, especially because we're not going to pull another vacuum on this thing. I know we opened this thing up and exposed it to air, but since there was vapor coming out, that means there was a very slight positive atmospheric pressure in here, which means almost no air got in. And if any air did, it's such a little amount, it will not explode, there will not be issues, because this is such a big volume of a chamber that we need to pretty much force air in with a fan, right? For that to happen with this little hole here, right? So now, the long part, just torque everything down. Actually, how many? There's 4, 8, 12. So I got to torque down all 12 of these things. Start a little bit light on the corners, and then we start to kick up the intensity once everything is in place and not gonna shift one way or the other from the torque. So I do the 4 corners first, and then we go crazy. Torque this thing down. All right. So you see, this is why it seals, because it can't go anywhere. Even under pressure or under vacuum, it can't move. It's like completely stuck. because of this high torque. So this is how it works. And this is why the RTV really does not even need to set for this thing to be sealed. So now this is back on. Now we have to mount the magnetron back on. Okay? So, magnetron. Magnetron goes back on. Pretty simple. It's just 2 screws. Way less than 12. So this is an experiment right now, guys. Right now, you're watching a live science experiment because I have never used that material, that gasket material at that thickness right now that I'm using. So it could fail or it could work brilliantly. We're going to see. Because like I said, I'm always trying to find the next best material in terms of cost and in terms of availability and accessibility and, of course, material properties. Okay, so the magnetron does not need to be torqued on there hard at all. It just needs to be faced up against it like that. Now, mount the fan back on. Well, actually, I'll plug in the magnetron because you probably can't see that after I go ahead and put the fan on. So look, plug it back in. Transformer capacitor circuit right here. Boom. Of course, plugged. It is off. Okay, and plugged off. I don't even have it plugged in. Okay, I do both because I don't mess around with this crap. Because you know what? What about if you're like, you have it? Okay, you have it plugged in, but you have it turned off. But what happens if something accidentally switches the switch? You know? Could be natural, could be supernatural, could be whatever. Or could be you. You could accidentally do it. You know, you could step on it or butt dial the switch or something, right? Not gonna catch me lacking like that, personally. I'd just rather not even take those odds, okay? I've been shocked by this fan a few times because the damn capacitor on it. It's a goddamn fan. The heck, you know? Let alone all this. So, oh, most important too. You see this right here? This green wire. This is my ground for the magnetron. You have to ground your magnetron. First of all, it won't work if you don't. But second of all, if you don't ground it, and if it's electrified and you touch it, or heck, you touch this whole chamber, you're the grounds. Electricity's going to you. So actually, it didn't take as long as I thought it would. We got the gasket back on, and what I like to do is I like to pressure test it, but we cannot, guys, we cannot pressure test this right now, or it will explode. Because right now, this whole chamber is full of flammable gases. Okay, so we cannot pressure test it. The only thing we could potentially do is vacuum test it, but I'm not going to vacuum test it because, I'll tell you why. These gaskets actually hold up better to pressure than they do to vacuum. They fail to vacuum pretty quickly under a heavy vacuum. Since the RTV is not set, it only gets set for microwaves, and since it's not set yet, putting it under vacuum will almost guarantee its failure. So ironically, the best thing we can do is turn the machine back on like nothing happened. And if it pops again, it pops, you know? If it pops again, then at that point, the only thing I could do after that is just, you know, do the old-fashioned way, which is when you wait for it to set for 24 hours before you run the machine. But the good thing is, only one popped, okay? We only had one of them pop. So, there's always... That means that my other ones, because all of them are different, okay? They're all different, so since only one popped, that means that my other ones are holding up and passing the test. Okay, so, like I said, we got almost no air in the chamber. Definitely not enough air to mix with the vapors and cause any type of combustion. Now, I say that confidently to you, but it really doesn't mean much to me. Because I know there's almost no air in there, but I'm still going to put on everything I can to make sure that I'm safe, as if it's going to explode. Because, yeah, like, I don't like to take the chances. It's very windy out here. Very, very windy. So, alright guys, so what we're going to do now is fire it back up. Let me see how I get Facebook going. Facebook has not been liking the live stream today for some reason. We'll see if we get Facebook going, and if we can, then we do. If we don't, then we're gonna get started. Anyways, if it works, guys, this will be cool because this will be the first ever time I've ever repaired it on live stream, and it worked. In fact, I never repaired it on live stream before. So it'll be cool if this does work. I'll be happy. All right, Facebook should be good actually. Facebook should be good. All right, cool. All right, guys, so we're gonna turn this back on. Now, hey, the protocol remains the same. We stay safe. We do small prayer before we turn it on. We don't play these games. I put all my safety stuff on. I know you're probably like, well, why doesn't he have boots? In fact, I probably will put my boots on because there's a small but serious chance it could explode right now. If somehow air got sucked in a lot, okay? Now, I don't believe that air got sucked in a lot. We literally saw the air being pushed out. But it's always a possibility, okay? There's a small chance. It's a real percentage chance right now that this could explode the minute I turn on the first magnetron. In fact, we'll know if it explodes as soon as I turn on just one. So let's just turn on one first. So if it does explode, it's not going to be 5 times worse, right? Because one magnetron will create the spark and heat necessary to ignite an explosion. So that's all we need on to do this. So let me go live on Facebook, and we're about to go ahead and turn this on. I don't like how windy it is. I don't like how windy it is for doing all this, but let me get my boots on and we're going to do this. Small prayer every time we got to turn this thing on too. Alright, so once again, if it's going to explode, it's going to explode from just even turning one on. We don't have to turn 5 on to know. So I'm going to start with just one with my remote from a distance, okay? I have my remote from a distance, so I'm going to be in the back. I still have all my stuff on, my face shield, my respirator. Like I said, I really don't think it will, but I take the precautions. good. We're good. No explosion. That's it. You didn't even hear anything. Underwhelming, right? All I did was just turn on the magnetron. There's a whole bunch of flammable vapors in here, so turning it on, if there's oxygen enough for the stoichiometric ratio to cause an explosion, the magnetron will cause the spark to cause the explosion. So now, turn the blades on, turn the fans back on, let's get back to business, and let's hope that this gasket holds up. Let's hope the gasket holds up, alright? I guess now we're gonna really see, we're gonna put it to the test. Let's do it. All right, everything's good. Everything is good. We don't have any explosions. We don't have any leaks. I did hear some weird sound, but I think it was a fan or something. So now we wait. We wait to see how the vapors form. What do they look like? How many vapors are we getting? But everything is on. I'm going to do a walk around and make sure everything looks good. Nothing is blatantly going wrong. All right, everything looks good. According to this, we got a little bit of positive pressure in there. Just a little bit. Under 1 PSI. It's probably like 0.10 PSI. But I like to confirm that it's not a fluke, because if I unplug this, you're going to see it drop a little bit, the needle. You see that? It dropped just a little bit. Plug it in, goes back up. So we have a little bit of positive pressure. That's fine. You know, pyrolysis, the highest pressure I've ever seen is 3 psi in my machines. All right, we do have vapors. We do indeed have vapors coming out. Okay? So that's good. So that means we're up and running. We're golden. Let's see if my lighter works. I left it out in the rain. Well, it probably doesn't, does it? Yeah, look at all that damn water in this thing. Probably is not going to work. Oh, it does. Okay. So, it's working. Now, unfortunately, I have to do something very scary for me. Okay? And what's very scary for me is I need to load in more plastic now it's running. This is the whole point of this experiment. So I have to. As it's running, as it's on, even though we just got this thing sealed and working. If you take a look at the view glass, you can see it is starting to become foggy, so that's good. But yeah, now I have to do this. I have to go and load in more plastic right now. Yeah, that view glass is getting real foggy. That's what we like to see. Yoga ball is filling up. All right. So just to break down everybody so you know how it works. We put plastic in the top. We open the top valve you see up there, right? Okay, so plastic is in that middle chamber where the glass is. Close the top valve. We pull a vacuum to suck out all the air. Okay? Suck out all the air and then open the bottom valve. So now the plastic with no oxygen in it falls in the chamber. So that way, since there's no oxygen, we won't have any explosions and no oxidation. Okay? That's how we do it. See if we got some heat. It's warming up. It's warming up. All right, so time to load in more plastic. And I'll tell you guys why it's scary. It's scary because when I'm loading in this plastic, I'm up high and I'm so close to this machine. I'm face to face with it. I'm as close to this machine as Diddy was to Meek Mill's face, okay? So if something happens and I'm right there, an explosion, it's going to be extra scary. But it's okay. Let's load in more. Let's do it. All right, that took a little bit longer than I wanted because I was doing some things. But it's hard to see from where you are. But that view glass where I load plastic in is now foggy. We got new plastic loaded in the machine. I'm going to be continuously loading it in. But what I want to do is show you. Obviously, the yoga ball is filling up. For everybody that wants to see, the yoga ball is filling up. Okay, it's no longer flat. Okay, my balls are being filled. My balls have been sucked and they are going to be filled, so there's no complaints. Let's see if we got some natural gas coming off though. Okay, this sight glass is super cloudy. I like that. Oh my goodness, there's a lot of gas coming off. In fact, there's so much gas, it's such a jet of gas coming off that I can't light it because it's shooting out at such a jet that it's like blowing itself out. Let's see what pressure we're at. Yeah, the pressure has gone up. The pressure has gone up, okay? Now, guys, I'm also ordering a digital. Okay, I'm ordering a digital one too, so we know the exact numbers. But it's probably at 0.5 psi right now. And that makes sense. I always said that. I always said, as we load in plastic, that just makes sense, right? And we see this happening. That's not a bad thing. So that's a W right there, okay? So we're gonna load in some more plastic. I'm gonna load in more. That's the whole point of this experiment. This is a science experiment. This is research and development right now. We're seeing what the effects of the machine happen as we load in plastic while it's running, okay? So we're experimenting, we're learning what happens. I don't know if you guys saw the smoke, but as I was loading in plastic, this transformer on this side started smoking. It overheated somehow. I don't know how. I don't know if it's dead or not because I can't hear it because there's so much other noise going on. So as far as I know right now, we only have 4 magnetrons operating. Okay? But we do have more plastic in there. I am still learning myself the best way to load this plastic in. This is research and development right now. So other than the magnetron or the transformer potentially completely dying, everything else is fine. The gasket's not leaking. Let's see if we have some flammable vapors. If they're not coming out too much this time, maybe they might light. Not quite. It's probably still getting up to temperature. We really don't start to see the results we want until this thing gets hot. And we've had to do a lot of things in between. I'm not sure why TikTok is lagging so bad. I have it on Ethernet. Let's see, temperature. Now, I will tell you guys something. Let me tell you something. We only have 5 magnetrons. Right now, we only have 4. Most of the magnetrons, 3 of the 5 are in the beginning. We have the blades on the whole time. That means that plastic is being pushed away from the main source of power. Okay? So, until I have at least 9 magnetrons, 3 on every section, what's probably happening is the plastic is probably reaching the end of the machine. You said, do you have a P.O. box? I do have a P.O. box, a citation sloth. If you send me an email, I'll send it to you. So the plastic I put in the beginning, when we first started this run, is probably already at the end of the machine. And the magnetron at the end of the machine is off because the transformer died. So what probably is happening is all the plastic that we want to be broken down is not even being touched by microwaves because there's not microwaves on in that area. Okay? So, the best thing I could do then is actually probably put the blades on reverse. Now here's the issue. Sometimes when I put the blades on reverse, it does some weird things. And I've had small explosions happen. Sometimes the machine does not like them reverse, okay? But that's probably the best solution right now. I guess it's a real stress test, right? See what will happen. We're going to turn the blades on reverse instead of forward and see if that will help us get some more vapors coming out. Because right now we have okay vapors. Or I have another option too. I can actually just load in more plastic. But the best thing is to put them on reverse. Okay? That's the best thing we can do. Because putting them on reverse will move all the plastic we put in back towards the beginning where all the power is. Okay? So I'm going to do it. Put it on reverse. So the blades are reversed. And the reason why sometimes this will cause small explosions is because when they reverse the plastic, they unleash a whole bunch of gas pockets sometimes, all at once. And if my gaskets don't hold up, they blow. Oh, I see the yoga ball. Watch the yoga ball. The yoga ball is actually starting to fill up. So I think it's working. I think the theory about putting it in. We're going to move all the plastic we put in back towards the beginning, since that's where all of our power is. See how it like sometimes like, yeah, sometimes reverse does some weird things. I'm actually looking at the sight glass. You won't be able to see this, but I can literally see the sight glass is actually pretty full of vapors right now. I can literally see the vapors like falling down. So once again, this is not the intended use of this machine. The intended use of this machine is the blades are always on forward. The plastic is always being broken down and moving towards the end of the machine. But since we don't have enough power, we're still test running. We're still doing low power test runs relative to the size of this machine. So we're just, just trying to figure out what works with where we're at. I'm going to turn this transformer back on, the one that was smoking out, and let's see if when I turn it back on, will it still be smoking. But I think it's done for. Usually when these transformers smoke like that, it's over. And that's why I have this fan over here to kind of cool off the transformers, but sometimes, clearly today, that didn't happen. All right, well, it turned back on. I don't know for a fact, is it working? Because I cannot, I always can tell by transformers by their sound. Never mind, it's smoking again, it's done. That transformer's donezo. Okay, it's a donezo transformer, it started smoking again. Shortly after it turned on. But guys, guess what? Thank you for the badge, Jabba Juba TV on Instagram. I appreciate you, man. Thank you, Carlos, for the $2 on Cash App. I appreciate you for your donation, Carlos. Much love to you, man. So right now, only 4 magnetrons. This is not looking good. Thank you for the badge, Laterra, on Instagram. I appreciate you, Laterra. You said touch the transformer. Haha. Got me messed up. This is not looking good. We only have 4 magnetrons right now. So there's no way this thing is gonna do good because we don't have enough heat. There's no way. But good news, we replaced the gasket. That new material I'm testing is working. We're putting the blades on reverse. No explosion. Put the blades on forward. No explosion. So it's still a win. It just sucks that the transformer had to die, right? Like what? Look, it's rare for transformers to die too. Okay, very rare. So it's like of all times. All right, I got one more card up my sleeve. We got the blades on reverse. Let's load in more plastic with the blades on reverse and see if we get anything from that. If not, then we're just gonna have to do another run tomorrow when I repair this transformer because there's just not enough power. I can feel it. This thing is pretty much cold. This whole body should be so hot I can't touch it. And it's windy anyway. It might be about to rain. I hope it doesn't. Please. Please don't rain on me. Because I don't need rain in the middle of all these electronics on, okay? The forecast said it won't be raining anymore, but we know who controls the forecast. Alright, let's load in more plastic with the blades on reverse. This will actually be the first time ever loading in plastic while the blades are on reverse. So, first time for everything, let's do it. So new plastic was loaded in. Don't really see any result of anything. And actually, the only thing I see is that it's starting to drizzle out here, which I don't like. I don't like the fact that it wants to drizzle with all these electronics on. So before the rain picks up, I gotta end the live stream and turn all this off. It's gonna become way too dangerous. It's already wet out here from it raining all day. We can't have this whole thing getting wet. But we don't see results anyway because not enough power because we lost the transformer. So guys, what I'm going to do, let me tell you what the plan is, okay? Let me turn this off first. Safety. Of course the forecast lied, right? So I talk about this all the time to people because people do like to, ask. Now, rightfully, people like to ask this rightfully because it's a great question about efficiency and such. And I've built 4 of these machines. Well, now I've built 5 because this is the 5th one. And let me tell you something about these machines as they get bigger. As the machines get bigger, from my experience of building them, they get more efficient. But they actually become only efficient once you get enough power in them, where they have enough heat. Until you get enough power and heat in them, they're extremely inefficient because they just can't, the plastic is just not being broken down enough. There's not enough power for how much volume there is. I have been observing, okay, I've been observing, and I noticed that when we have the 3 magnetrons in the first chamber at the beginning, that first chamber is actually getting hot enough. So 3 per chamber is the minimum. Right now, I have 3 in the beginning, 1 in the middle, 1 at the end. That means that we need 9 minimum before this thing will actually be able to provide us any actual usable numbers. And we're talking efficiencies, because there's just no way that it can effectively convert as much plastic into fuel as we're putting in there when there's not even microwaves in the areas getting down, where it's getting down to, right? So just for reference, for my YouTube people, because my YouTube people know, because they saw Mark IV, and they saw me building Mark IV, and they were there when I got my high efficiency runs and numbers on Mark IV. 25 kilowatt hours in, 48.8 kilowatt hours out. We got to that point by using a minimum of 3 magnetrons. If you go on YouTube, I tried using just 2, because one day one of my magnetrons broke, and I was like, let's just use 2. And the issue with when you do too little power is you have to do a way longer run to get the same amount of products out. Way longer run means more electricity consumed. So the idea is we have so much power going in that we load plastic in, and by the time it reaches the end of the chamber in like 5 minutes, it's all broken down. It's all carbon. It's all been turned to the fuels, right? And then we continually load in more plastic. And since plastic has so much energy in it, as long as we're loading in plastic, we're going to be able to break that veil or that ceiling of the energy input-output. That's the idea. That's the idea of the continuous operation. But we won't get there until we, 1, have enough power, and 2, have a way to load in way more plastic as it's running than what I've been doing. Because a lot of the plastic gets stuck up in the chamber, and I got to sit there diddling around with the valves to get it to all fall in. So we got to solve those 2 problems first, And then after we solve those two problems, at that point, we will be able to effectively run this machine. And I hypothesize, get an energy profit just like we did on my last machine. In fact, the energy profit, so my last machine was almost double. This, I want triple, quadruple, okay? And I say that because it's going to operate continuously. Once the machine gets hot, it's going to stay hot while we load the plastic in, which will, in every way, help break it down with less energy. In fact, it can get to a point where once the machine gets hot enough, maybe we only need to keep on half the magnetrons, right? Stuff like that. We figure out with time. But nonetheless, I'm glad that the gasket situation worked. I did not think it would, to be honest. Okay? I did not think the gasket would hold up, but it did. The transformer did not. That's okay. So, like I said, tomorrow I'm going to actually build the next waveguide. So we'll have 3 at the end, 2 in the middle, and 1. Wait, I said that wrong. 3 in the beginning, 2 in the middle, 1 at the end. That's the goal. 6 magnetrons going in this thing. Okay? And that's the max I can run off of my home 50 amp circuit. That's the max. I can't run more than 6. Unless I get them operating off a 220. But since they operate off a 120, they pull too many amps for my circuit. So, and unfortunately, these transformers are strictly 120. But I'm actually looking into getting some 220 transformers. They're just very expensive. So anyways, that's what we'll do. Hopefully, these waveguides take all day to build. But hopefully, I can build it. And clearly, since the gasket's set quickly, we can actually run this thing tomorrow as well. We'll see. But I appreciate you all for stopping by. Thank you all for the donations. I will see you guys tomorrow. We'll run this thing. And look, guys, I'll say this last thing. When we get the Goldilocks zone with enough heat going in, that is going to be when we start getting oils. And when we start getting oils, it's a done deal, okay? Well, not exactly, but it is very cool, okay? So, all right, I'll see you guys tomorrow, hopefully.